Okay, so this question is giving us the concentration of a weak acid, and we're asked to find the Ka value. And the other piece of information that they've given us is the pH at equilibrium. So if we have carbonic acid, this is H2CO3, and if it reacts with water, we're going to have a transfer of protons from our acid to water, and we'll be left with HCO3 and hydronium ions. So remember that because this is a weak acid, this will not be 100% reaction. Okay, in fact, it'll be quite a small percent of these molecules that actually react to form hydronium. So we can figure out the hydronium concentration because we know what the pH is. So hydronium is 10 to the negative pH. So we can figure out what our hydronium concentration is at equilibrium. If we sub into our ice table here, we've got H2CO3, H2O, hydrogen carbonate ions, and hydronium ions. So we can find what the concentration of hydronium is at equilibrium. Remember that we never include liquid water in equilibrium expression, so we don't have to worry about filling out any information for that. So if we calculate 10 to the negative pH, that's 10 to the negative 3.48. This is equal to 0.00033. So this is our value at equilibrium for the hydronium concentration. So we can substitute that in. So it's a very small amount of hydronium produced, which makes sense because it's a weak acid. So we don't expect to get a lot of hydronium. We can start subbing in the other values. I know that initially there would be 0 of these present until it's reacted. So the change, would be plus 0.0033. Same thing for this guy because these are a 1-to-1 ratio. If we take a look at the hydrogen carbonate, the initial concentration is 0.25 mole per liter. So that's the concentration of my acid of my solute. And the change will be minus, again, because it's a 1-to-1 ratio, it's going to be minus 0.00033. When I sub in the value at the end, so 0.25 minus 0.0003, it's such a small change that when I round to 2 significant digits, I actually just end up with the same number. Okay? So now I have all my values at equilibrium, and we can solve for Ka. Ka is products over reactants. So we've got 0.00033 for both of our products, and then 0.25 mole per liter for my reactant. When we calculate this, we get a Ka value of 4.4 times 10 to the minus 7. And if we look in our data book, this answer should be close to what's given in the data book for the Ka value. So find carbonic acid, which is right here, and our Ka is 4.5. So we're pretty close to that value, which we would expect it to be for carbonic acid.